You can solve this by reverse chain rule or by substitution. I'm going to use substitution in this case. So if I were to set u to be equal to x squared plus x plus 5, then that obviously simplifies our denominator, but also the differential of this, du dx, would be 2x plus 1, which is the same as the numerator. So whatever you set your u to be when you do substitution, when you sub it in, you'll end up dividing this integral by whatever your du dx is. So that would mean that the 2x plus 1 here would be divided by this 2x plus 1, and they'd cancel out, and we'd be left with 1 over root u. If that doesn't make sense, I've basically just described the steps of integration by substitution. So if you can't see that in your head, I'm going to go through it, and you'll see how that works. The better you get at substitution, the faster you'll be able to do these steps in your head, and then you'll be able to better pick what substitution to use. Alright, so then rearranging what we have over here, dx then becomes 1 over 2x plus 1 times du. So hopefully you can see now why when we replace the dx with this, we're dividing by the differential of u with respect to x, which is this. Okay, so let's put this in. This then becomes the integral of 2x plus 1 over root u multiplied by 1 over 2x plus 1 du. And then these two things cancel, and we're left with the integral of, so 1 over root u would become u to the power of minus a half, and then we can integrate this. So raise the power by 1, u to the power of a half, and then divide by the new power, divide by a half, plus c, which is 2 lots. So if you were to do something, or rather not something, 1 divided by a half, that would give you 2. So it'll be 2 u to the half plus c, and then we can just change the u into x squared plus x plus 5. 2 to the power of a half is square root again, so I've just changed that back. You don't have to. So we get this, and then plus c.